Welcome guys to the channel. If you haven't subscribed, kindly do so and remember to click the notification button to get more amazing content. And with that, let's go straight to the video. Astronomers have found a secret planet-making ingredient, magnetic fields. We like to think of ourselves as unique. That conceit may even be true when it comes to our cosmic neighborhood, despite the fact that planets between the sizes of Earth and Neptune appear to be the most common in the cosmos. No such intermediate mass planets can be found in the solar system. Problem is, our best theories of planet formation, cast as they are from the molds of what we observe in our own backyard, haven't been sufficient to truly explain how planets form. A new study, however, published in Nature Astronomy in February, demonstrates that by taking magnetism into account, astronomers may be able to explain the striking diversity of planets orbiting alien stars. It's too early to tell if magnetism is the key missing ingredient in our planet formation models, but the new work is nevertheless a very cool new result. Until recently, gravity has been the star of the show. In the most commonly cited theory for how planets form, known as core accretion, hefty rocks orbiting a young sun violently collide over and over again, attaching to one another and growing larger over time. They eventually create objects with enough gravity to scoop up ever more material, first becoming a small planetesimal, then a larger protoplanet, then perhaps a full-blown planet. Yet gravity does not act alone. The star constantly blows out radiation and wind that pushes material into space. Rocky materials are harder to expel, so they coalesce nearer the sun into rocky planets, but the radiation blasts more easily vaporized elements and compounds, various ices, hydrogen, helium, and other light elements out into the distant frontiers of the star system, where they form gas giants such as Jupiter and Saturn and ice giants like Uranus and Neptune. But a key problem with this idea is that for most would-be planetary systems, the wind spoils the party. For some time now, scientists have suspected that magnetism may also play a role. What specifically magnetic fields do has remained unclear, partly because of the difficulty in including magnetic fields alongside gravity in the computer models used to investigate planet formation. And yet, magnetic fields are commonplace around planetesimals and protoplanets, coming either from the star itself or from the movement of washed gas, starlight, and dust. In general terms, astronomers know that magnetic fields may be able to protect nascent planets from a star's wind, perhaps stir up the disk and move planet-making material about. We've known for a long time that magnetic fields can be used as a shield and be used to disrupt things. Magnetism seems to have three key effects. First, magnetic fields shield certain clumps of gas, those that may grow up to be smaller planets, from the destructive influence of stellar radiation. In addition, those magnetic cocoons also slow down the growth of what would have become supermassive planets. The magnetic pressure pushing out into space stops the inflation of new matter. Maybe not completely, but it reduces it a lot. The third apparent effect is both destructive and creative. Magnetic fields can stir up gas. In some cases, this influence disintegrates protoplanetary clumps. In others, it pushes gas closer together, which encourages clumping. Taken together, this influences simulations only examine the formation of gassy worlds. In reality, these prototypical realms can create solid material too, perhaps becoming rocky realms instead. Altogether, these simulations hint that magnetism may be partly responsible for the abundance of intermediate mass exoplanets out there, whether they are smaller Neptunes or larger Earths. The researchers don't claim that magnetism is the arbiter of the fate of all worlds. Instead, magnetism is just another ingredient in the planet-forming process. In some cases, it may be important, in others, not so much. Which fits, once you consider the billions upon billions of individual planets out there in our galaxy alone. Thank you once again for watching the video. I hope it was informative. Kindly like, subscribe, and click the notification button.